Hi, I'm Mary, and this is another magical math moment. Yes, I'm still fighting the funk and sound a little weird. In this video, I am going to talk a little bit about solving polynomial equations, finding zeros, and doing quick sketches. Before we jump into that, we should discuss just briefly here what some of these functions are going to look like. So we're going to have odd degree functions and even degree functions. Disclaimer, I'm not talking about odd and even functions. That's something later in the course. I'm just looking at the leading the leading term, and looking at that degree. So if I have something like y equals x, hopefully you all know, it's this beautiful graph here. If I have a negative out front, it flips direction, right? So with an odd degree function, we start low and go high. Unless there's a negative out front, it starts high and goes low. The end behaviors are not the same. This is similar with x cubed, although it does like a little funny thing in the middle here. It goes up and then it kind of curves like so. If it's negative out front, it starts like that and curves like so. Try not to make them vertical like I did here. That's kind of trashy, but you can kind of see like they're always going out, okay? If it's vertical, it's not a function. So our odd degree functions, they always start low and high. Unless there's a negative out front, it flips around. With the even degree functions, x squared, you guys probably remember that. That's a parabola, right? So that kind of comes in, oh my gosh, and does like that. Not a fan of the quick sketch, especially when it's on camera. If it's a negative x squared, it's just going to flip down. So it's going to do something like that. Oh my gosh. Hopefully yours looks more symmetric. When you have x to the fourth, it's going to look very similar, except it's going to be a little bit like flatter down here. And if it's negative, it's going to flip and be a little flatter. So the larger the degree, the flatter this is going to be kind of when you look at it. And if you want to explore it, you can look at a calculator and pull up exact points. So even degree functions have the same end behavior. They start high, end high, or they start low and end low, okay? This is true for any even degree, 2, 4, 6, 8, etc. Same thing for the odds over here, 1, 3, 5, 7, okay? So use that to kind of help you. Let me see if I can leave like a nice, yeah, that's nice if you want to take a picture real quick or screenshot. All right. To kind of have a general idea of how graphs look, we can use something called the leading term test, which basically says, given any function, if you look at the leading term, the function will have the same end behavior as the leading term. So if you're trying to have a general idea of what something's going to look like, the negative tells you that it flips. The degree is 5, which is an odd number. So hopefully from the other page, you know this is going to start high and it's going to do something like that. Now, because of all these other variables, it's not going to be that straightforward, right? It's going to come down. It's going to do some kind of loopy-loop thing. I'm not entirely sure what it looks like. That's just a quick sketch, okay? I'm going to do one with you in a minute, and you'll be able to see how to do a better quick sketch. If you've got something like this big function, again, look at your leading term. It's positive, so it's going to be opening up. It's even, so they have the same end behavior. So if you're doing a quick sketch, it's going to do something like that, okay? And again, because of all the variables, it's not just going to be something like this. It's going to come down. It might do something like that, okay? So keep that in mind as we look at this next one. We're going to find the zeros and sketch this beautiful function. So first thing I'm going to do is set it to 0 and see if I can try to get any kind of factors here. Which, honestly, I'm looking at it. There's no way I know how to factor that. So I'm not doing that. I'm going to go into the calculator and see what I can find. X to the fourth minus 5x to the third plus x squared plus 21x minus 18. Well, okay, so that's kind of pretty. So what I'm going to do is I'm going to pull one of these zeros. So this one looks nice over here. That looks to be 2 or 3. If I go in the table, I've got 3. I can really just get all of my zeros from this, right? -2, 1, and 3. Now, if your goal is just to do a quick sketch, then you would be good going off of this information. But if they're asking you to find the zeros as well, we have to also consider multiplicities, which when you look at this thing, hopefully you notice that that's happening here at 3 because the graph is bouncing off the axis, right? So let's use one of these zeros to do some synthetic division. Let's start with 3 because it's positive. So I've got 1, -5, 1, 21, -18. Here we go. 1 drops. 1 times 3 is 3. Subtract, you get -2. 2 times 3, -6. Combine -5. -5 times 3, -15. Combine 6. 6 times 3, 18. Remainder 0. All right, so now I am left at x cubed minus 2x squared minus 5x plus 6. I'm kind of thinking of what this would look like to try to group. It's not going to work. So now I'm going to try out my next 0. How about we try 1? So we got a 1, drops down. 1 times 1 is 1. Combine here, -1. -1 times 1 is -1. Combine -6. Multiply. And there we go. That's our remainder. Now I'm left with x squared minus x minus 6. Are there factors of -6 that add to -1? Yeah, there are. So I can go ahead and set this up and factor it. X minus 3, x plus 2. Aha. So now I get x minus 3 is 0, so I know x is 3. This one, x is -2. When I go back to look for my zeros, I have 1, 2, 3, 4. Okay. So x equals 3 occurs twice, so I'm going to say multiplicity 2. And then I also have 1 and -2. And those are my 4 solutions. Now remember, when you're dealing with polynomial functions, your degree is going to dictate how many solutions you have. So 1, 2, 3, 4. Not too bad, right? If I were to do a quick sketch of this thing, we already know because we looked at the graph. We're going over to 3. We are going over to 1 and also -2. Because this is 4th degree and the leading term is leading coefficient's positive, we start high. I know the multiplicity is at 3, so that's where it's going to bounce off. So this first 0 cuts through, the function cuts through the axis at the 0. It's going to go back up around. It's going to cut through here, change direction again, and hit this 0 and go back up. So, again, quick sketch, not precision, but it has a general shape. Okay, when you're doing a sketch, it's okay to just have a quick sketch. You want to have your zeros in place. You want to account for a multiplicity where it bounces off the axis. And that's that. I hope that this has been helpful for you. And I thank you for joining me for another magical math moment.